Hello everyone, welcome you all to this video lecture. This is Selva Brinda, Assistant Professor, Department of Artificial Intelligence and Data Science from Ramco Institute of Technology, Rajapalayam. Today we are going to see about some of the basic concepts of Hadoop. So before getting to know what is Hadoop, let us rewind to the days before the world turns digital, that is around 1990s. So at that time, only a small amount of data was generated, and almost all the data was in the form of rows and columns, that is in the structured format. So storing or processing this type of data was not a much trouble because a single storage unit and a processor is enough to do this job. So as years passed by, that is around 2000, internet generates tons and tons of data every minute and even in every microsecond. So let us have a look on how much data generated every minute on the internet from the social media platforms like Instagram, Snapchat, Facebook, Google and Twitter. So the magnitude of the data generated will definitely surprise you. Here are some of the amazing facts about the amount of data generated every minute on the internet. 2.1 million snaps are shared on Snapchat, 3.8 million search queries are made on Google, 1 million people log on to Facebook, 4.5 million videos are watched on YouTube, 188 million emails are sent, and 87,500 people are tweeting. So, from this statistics, it is observed that the amount of data available today is immeasurable, and also not all the data is created equally. Some data may be in structured format, some data may be in unstructured format, and some data may be in semi structured format. So let us see what is structured data, semi-structured data and unstructured data. So structured data is nothing but it is a quantitative data in the form of numbers and values. It is highly organized and stored in a predefined format. Semi-structured data is a type of data that is not purely structured but also not completely unstructured. Unstructured data is a qualitative data which does not have identifiable structure and is not organized in a predefined manner. So some of the different forms of data generated in the internet includes email, images, video and then audio. All these structured, semi-structured and unstructured data becomes the big data. So, data generation is the beginning of big data. What is big data? Big data is a collection of data that is huge in volume yet growing exponentially with time. Data generated through all the new technologies like smartphones, self driving cars, and computers comes under the big data. Some of the characteristics of big data includes volume, veracity, velocity, variety, and then value. So these are called as the 5 V's of big data. So let us see what is volume. Volume is a huge amount of data that is generated every second in the range of terabyte or petabyte. Variety refers to different types of data from different sources like structured data, semi structured data, and unstructured data, what we have seen earlier. Next is the velocity. Velocity is the speed at which the data gets generated. Next is the variety. So, the degree to which the data can be trusted. So, it indicates the data reliability and trust. That is, it verifies and validates the data. So, value. It indicates the usefulness of the data. Having access to big data is well and good, but that's only useful if it is turned out into a meaningful value. So, considering the volume of data, variety of data generated, speed of data generated, so considering all these aspects, it is very difficult to store and process this big data. Then, how do we store and process this big data? So, there comes the need of big data frameworks. So, what is a big data framework? Big data framework is an ecosystem of different components which play an important role to process, handle, and store large data. They are made to analyze big data rapidly, effectively, and securely. So, big data frameworks are often open source, which means they are generally free with the option to purchase support if necessary. Some of the big data frameworks include Apache Hadoop, Apache Spark, Apache Hive, and then Apache Storm. So these are the big data frameworks. Out of these big data frameworks, today we are going to see about Apache Hadoop. So let us see the origin of Hadoop. How Hadoop is originated. So Apache Software Foundation formed as a non-profit organization in the year 1999. Hadoop has its origin in the early era of World Wide Web. As web grew to millions and billions of pages, the task of searching and returning search results became the major challenges. So companies like Google and Yahoo, they started to build a frameworks to automate these search results. So one such project is called as the Nudge. So this project was created by Doug Cutting and Mike Caffarella in the year 2002. In 2006, Cutting joins the company Yahoo and he takes the Nudge project along with him. So, while dealing with the Nudge, they are dealing with the big data. So, to store the data, they have to spend a lot of cost. So, this becomes the significant reason for the emergence of Hadoop. So, Cutting introduced the concept called Hadoop in the year 2008. So, Hadoop is an acronym for High Availability Distributed Object Oriented Platform. So, it is named after Cutting's son's toy elephant. So, that's all about the origin of Hadoop. So, let us see what is Hadoop. Hadoop is an open source software framework used for storing and processing big data efficiently in a distributed manner. So Hadoop is licensed under the Apache v2 license. Hadoop is written in Java programming language. Some of the components of Hadoop includes HDFS, MapReduce, and then YARN. HDFS is a storage unit, MapReduce is a processing unit, YARN is a resource management unit. So the first primary data storage unit is the Hadoop, Hadoop distributed file system. So storing massive data on one computer is unfeasible. Therefore, data gets distributed among many computers and they are stored in a blocks and this concept is called HDFS. HDFS is a distributed file system that handles large data sets running on commodity hardware. This HDFS follows the master slave architecture, means it consists of two components like name node and then data nodes. So it has a single name node and multiple data nodes. So this single name node performs the role of a master and this multiple data node performs the role of a slave. So this is the architecture of HDFS. We have a name node, we have a data node, and inside the data node we have some blocks where the data gets stored. So name node is used to store the metadata. When HDFS takes in the data, it breaks down the information into separate blocks and distribute them across the various data nodes for storage purpose. So name node is aware of the status of each data node. Means name node monitors the status of data node. Which data node contains which blocks and where the data nodes are present inside the cluster. So all these details will be monitored by the name node. Name node manages access to the files including read, write, create, delete and replication across the data nodes. So consider if we have 560 megabyte of data with us. We need to store this data in HDFS. So how does HDFS works? So HDFS splits this 560 MB of data into multiple blocks of data that are stored on several data nodes inside the cluster. So, say for example, if the size of each block is restricted to 140 megabyte, then this 560 MB gets split up into four different blocks: block A, block B, block C, and block D, each having 140 MB size. If name node realizes one data node is not working properly, do we lose that particular data? Definitely not, because it can immediately reassign that task to different data nodes containing the same block because of the feature called data replication. So, in this diagram, the block A is replicated two times. So, this is the beauty of HDFS, and the data replication concept is explained in the upcoming slides. So some of the features of HDFS include high availability, fault tolerance, reliability, replication, flexibility, scalability, and data locality. So one of the most important feature of HDFS is data replication and fault tolerance. So as discussed earlier, data is divided into blocks and is replicated across multiple data blocks. So when one node goes down, the user can access that particular data from other machines. So with the help of the replication method, data is not going to be lost at any cost. So this makes the HDFS as fault tolerance. So in this diagram, we have a file and the data from that file gets split up into four different blocks: block 1, block 2, block 3 and block 4. So Hadoop replicates each block across number of machines. So here we have six different machines and these machines are considered as the data nodes. So all the machines are inside one single cluster. So the Hadoop replicates each block with a replication factor 3 here, which means block 1 is replicated 3 times, block 2 is replicated 3 times, block 3 is replicated 3 times and block 4 is replicated 3 times. So, data replication enables highly efficient parallel processing. So, that's all about HDFS component. So, after storing the data successfully, it needs to be processed. So, the next component, MapReduce, comes into existence. So, MapReduce is the processing unit of Hadoop. It can process and computes vast volume of data. MapReduce is considered as the heart of Apache Hadoop. So in this approach, the processing is done at the slave nodes and the result is sent to the master node. So there are two phases present in the MapReduce. First one is mapping Next is reducing. So in mapping phase, the data present in different data nodes gets mapped. In the reducing phase, it aggregates and reduces the output of different data nodes to generate the final output. So how does MapReduce works? So MapReduce architecture has four different components like mapper, combiner, shuffle and sort, and then reducer. Initially, input from each block gets split up to be processed by the mapper. So, the record reader communicates with the input split and converts the data into a key value pairs. So, this key value pair can be read by the mapper, and the mapper phase process the input and generates the intermediate key value pairs, that is k dash and v dash. So this condition logic is applied to n number of blocks present across the various data nodes. So in this diagram we have four different blocks. So this condition logic is applied to these four different blocks. Next, a component called combiner is present. So for each combiner there is a mapper. So combiner is also called as the mini reducer. So the output from the combiner reach the reducer based upon the decision made by the partitioner component. So partitioner component is a component present in between the combiner and the reducer. It decides whether the output can pass from combiner to reducer. So the output of the partitioner component is get shuffled and sorted and it enters the reducer phase. Finally, there is a record writer which writes the output from the reducer component to the output files. So finally we have a key value pairs. So this is how the map reduce component works. So let us see an example for the working of map reduce. So this is a MapReduce example to count the frequency of each word in a given input text. So here we have three different input text. One is deer, beer, river, and the second input text is car, car, river, and third one is deer, car, beer. So these three input text get split up into three keys and values. So after splitting is done, it enters the mapping phase. There a list is generated along a keys with its values. Say for example, from the first text, each word along with its frequency is displayed. So deer is occurred one time, beer is occurred one time, river is occurred one time. So each keys along with its value is given in the mapping phase. After that, combiner phase occurs. So this combiner phase combines all the inputs. After that, shuffling and sorting is done. So a keys along with the list of its value is generated. So in the shuffling phase, so that beer word from the first text and the beer word from the third text gets combined. Means beer of 1 comma 1. So after shuffling, it enters the reducing phase. So finally, we have a keys along with its values. So car is a word, it has a frequency 3. River is a word, it has a frequency 2. Deer is a word which has a frequency 2. So this is how the map reduce count the frequency of each word present in the given input text. So that's all about map reduce component. The third component is yarn. Why this yarn component is necessary? So Hadoop version 1.0, which is also referred to as MRV1, that is MapReduce version 1. In MapReduce version 1, MapReduce component performs both processing as well as resource management function. So this is the architecture of MapReduce version 1. Here the client provides the data to the job tracker. So this architecture follows the slave master concept as that of HDFS. So here job tracker is considered as the master, and there are subordinate process called task tracker. So the work of the job tracker is to allocate the resource, perform the scheduling and monitoring the processing of jobs. So the task of job tracker is to do the assigned map and reduce task, and it has to periodically report their progress to the job tracker. So this is how this architecture works. So job tracker was considered as the master, and this task tracker is considered as the slave. So this architecture has two limitations. First one is scalability bottleneck due to a single job tracker, and second one is utilization of computational resources is insufficient. So to overcome these two issues, Yarn was introduced in Hadoop version 2.0 in the year 2012 by the company Yahoo and Hartenberg. So this is the comparison between Hadoop version 1 and Hadoop version 2. In Hadoop version 1, we have only two components, that is HDFS and MapReduce. In version 2, we have HDFS, Yarn and MapReduce. So HDFS is used for the file storage purpose. MapReduce is used for data processing and resource management in version 1. In version 2, MapReduce is used only for the data processing and Yarn is used for the resource management. So, what is Yarn? Yarn stands for Yet Another Resource Negotiator. Yarn is the cluster management component of Hadoop. So, the basic idea behind Yarn is to relieve the MapReduce by taking over the responsibility of resource management and job scheduling. So Yahoo started to give Hadoop the ability to run non-MapReduce jobs within the Hadoop framework. Yarn infrastructure is responsible for providing the computational resources like CPU and memory needed for the application execution. So let us see the components of Yarn. Yarn has four different components. First one is resource manager, next is node manager, next is application master, and next is containers. So this is the architecture of Yarn. It has a resource manager, and inside the resource manager it has a scheduler and application manager. And we have a node manager. Inside the node manager we have a container and application master. So, resource manager is the master server because we have only one resource manager per cluster. This resource manager knows the location of data node and how many resources they have. So, this information is known as the rack awareness. Then, resource manager runs several different resources, out of which the most important resources is resource scheduler. So this resource scheduler decides how to allocate the resources. So this is the working of resource manager. So next is node manager. It handles the node and monitor the resource usage in the node, which means we have n number of node managers in one cluster. So they are called as the slaves of this infrastructure. Each node manager offers the resources to their cluster. Also, it monitors the resource usage in the containers. So, container is nothing but it is a collection of set of resources. So, this container is allocated by the resource manager on the basis of application. So, what about application master? So each application master requests the resources from the resource manager and then works along with the containers that is provided by the node manager. So application master acts as an interface between the resource manager and the node manager. So that's all about the working of the yarn architecture. So the resource manager is responsible for allocating the resources, and a container is allocated by the resource manager, and this container works along with the application master. Node manager contains the container. So next is how to run an application through yarn. So we have five different steps to run an application through yarn. First one is the client submits an application to the resource manager. Next is the resource manager allocates a container. Third one is the application master contacts the related node manager. And fourth one is the node manager launches the container. Fifth is the container executes the application master. So let us see these steps in detail. So the first step, the client submits an application to the resource manager. This is the first step. Next one, the resource manager allocates a container to do that application. So the resource request is sent. In the third step, the application master contacts the related node manager for the purpose of container. In the fourth step, the node manager launches the container needed for doing the application. So finally, the container executes the application master. So this is how the application is executed through yarn. So that's all about the components of Hadoop. We have seen what is big data and what is the big data frameworks, and in that we have seen one of the big data frameworks called Hadoop. What is the need of Hadoop and what are all the components of Hadoop? So I hope you all got a better understanding about what is Hadoop. So if you like the video, do like, share and subscribe. Thank you so much.